Guys, we're going to sketch function y of x and z of x in this next one. Now, y of x equals to 2 sine of 1/2 times x minus pi over 3. And we want to find the period, the interval value, the starting value, and the remaining grid values. And then you want to state the amplitude for the function. So, sure thing. Start off with the period. Now remember, to find the period of a trigonometric function, that is 2 pi over k. And k is a number that's being multiplied inside with x or outside of the parentheses containing x. The function y of x equals to 2 sine of 1/2 x minus pi over 3. My k, once again, is going to be 1/2. So to find my period, that is going to be 2 pi divided by 1/2, which equals to 2 pi times 2. Remember, using keep, change, flip, and that's 4 pi. So my trigonometric function will take 4 pi to make one complete revolution. To find my interval value, which I'm going to abbreviate once again as IV, that is 1/4 times the period. So 1/4 times my period of 4 pi, which is 4 pi over 4, and it equals to pi. So each grid value will be pi units apart from each other. The starting value. Now, the starting value is based on the horizontal shift. Here, we have a number being subtracted from the variable of x. Whenever there's a number being subtracted from the variable of x, that is a horizontal shift to the right. So we're going to shift pi over 3 units to the right, which means the starting value is going to be pi over 3. I want to find the remaining grid values. The first one is positive pi over 3. So I'm going to put that right here on my coordinate plane. To find the next one, we're going to add the interval value to the first grid value. So we're going to add pi. Once again, when we're adding fractions, they must have the same denominator. We can convert this pi right here to 3 pi over 3. Bring down the first grid value, and you can add. Once again, I'm not going to go over how to do that, but just know when you're adding fractions, they must have the same denominator. Pi over 3 plus 3 pi over 3 is 7 pi over 3. Well, excuse me, 4 pi over 3. My second grid value. Add another 3 pi over 3, which is the same thing as pi. That is 7 pi over 3. Add another 3 pi over 3. We get 10 pi over 3. We're going to do that one more time. Add one more 3 pi over 3. And that's 13 pi over 3. So this is my third grid value. That is my fourth grid value. That is my fifth grid value. So then we have 4 pi over 3. 7 pi over 3. 10 pi over 3. 13 pi over 3. Now, we want to find the amplitude for the function. For this first function, we have a 2 being multiplied in front of the trigonometric function. So the amplitude will equal to the absolute value of that number being multiplied in front of your trigonometric function. And the absolute value of 2 is 2. Which means the highest value my function is going to obtain is going to be positive 2. And the lowest y value my function will attain is negative 2. Now remember, this is a sine function. Sine function is 0. The maximum value, which is 2 in this case, back down to 0. Then the minimum value. Oop, put that in the wrong spot. And then back to 0. And after that, we sketch that function. And that is the function y of x. Now we're going to do the same approach when it comes to z of x. Now, let's find the period. To find the period, that is 2 pi over k. This value right here is your k. So that's 2 pi over 2, which equals to pi. Now we're going to find the interval value, which is 1/4 times the period. So 1/4 times pi. And that equals to pi over 4. So every grid value will have a distance away from each other of pi over 4 units. The starting value, I have a value being added to the variable. When I'm adding a value to the variable, I am shifting the function left by that many units. So I'm going to shift my function left by pi over 2 units. And when I do that, my starting value will be negative pi over 2 because I'm shifting to the left. And then define my other grid points, my other grid values. The first one is negative pi over 2. Okay, that's my starting. And I'm going to put that right on my coordinate plane. Negative pi over 2. To find the next one, I'm going to add the interval value, which is pi fourths. Now remember, when we're adding and subtracting fractions, we must have the same denominator. What I'm going to do is I'm going to convert this denominator of 2 into 4. So I can write negative pi over 2 as negative 2 pi over 4. Once again, I'm not explaining that step since I explained it already a couple of times. And then I'm going to add pi over 4 to that. Negative 2 pi over 4 plus 1 pi over 4 is negative pi over 4. That's my second grid value. Then we're going to add pi over 4 again. Negative pi over 4 plus positive pi over 4 is 0. Add another interval value again. 0 plus pi over 4 is pi over 4. That's the fourth grid value. Pi over 4 plus pi over 4 equals to 2 pi over 4. And that can be reduced to pi over 2. And that is the fifth grid value. Remember, you must reduce your fractions accordingly. The amplitude is going to be the absolute value of a. And remember, a is a number that you're multiplying in front of your function. So it's going to be the absolute value of 1/2. And the absolute value of 1/2 is just 1/2. So the highest value of y this function can obtain is 1/2. The lowest value this function can obtain is going to be negative 1/2. Now this is a cosine function, so remember the steps. The cosine function starts at the maximum value, down to 0, down to the minimum value, back up to 0, and ends on the maximum value. Let's sketch that function to the best of our abilities. And this is what z of x looks like. Now, we want to sketch b of x and d of x. B of x equals to negative 2 sine of 1/2 x minus 3. And d of x equals to negative 1/2 of cosine of 2 plus x, so 2 times x plus pi over 2. Now, in this case, and if you notice, these functions are almost similar to like the functions we did in part C. However, there is a negative in front. So when I want to find the period for b of x, the period will remain the same as the last one. It will remain the same as the last one. So my period is still going to be 4 pi. My interval value is going to be pi. My starting point is going to be positive pi over 3. Once again, that is a shift of pi over 3 units to the right. My grid values is going to be positive pi over 3, 4 pi over 3, 7 pi over 3, 10 pi over 3, 13 pi over 3. The amplitude is the absolute value of the number being multiplied in front of the function. So it is the absolute value of negative 2. And the absolute value of negative 2 is positive 2, which means the highest value this function can obtain is going to be positive 2. The lowest is going to be negative 2. And it says here, and the reflection. There is a negative being multiplied in front of the function. When there is a negative being multiplied in front of the function, it is a reflection over, write that better, but a reflection over the x-axis. So basically, we are reflecting y of x over the x-axis. And when you reflect over the x-axis, you're changing the sign of every y-coordinate. So let's set that function up. That's 1. That's 2. Negative 1. Negative 2. Pi over 3. 4 pi over 3. 7 pi over 3. 10 pi over 3. And 13 pi over 3. Now, sine usually starts at 0, goes up to max, back to 0, down to the min, and back to 0. But because of the reflection over the x-axis, it's going to start at 0. But then it's going to go down to the minimum. Back up to 0. Reaches the maximum. Back to 0. That is reflection over the x-axis. And that is how you sketch b of x. And then the same thing when it comes to d of x, which is negative 1/2 cosine of 2 times x plus pi over 2. The only thing that would change from part C is going to be it is reflected over the x-axis. So the amplitude is still going to be 1/2. My grid values will remain the same, as well as the period and also the interval value. Negative pi over 2, negative pi over 4, 0, pi over 4, and then pi over 2. Now remember, cosine starts at maximum, then it goes to 0, minimum, 0, maximum. Because it's reflected across the x-axis, it's going to start at the minimum, 0, maximum, 0, minimum. That is reflected across the x-axis. Oops, I put my point too far down there. I just noticed the distance wasn't the same. And this is function d of x. All right, guys, that is it to this video. I'm going to let you know right here and right now, when it comes to sketching these trigonometric functions, I made this section for section 7 and 8, maybe about an hour and a half, 2 hours long. I want you guys to get comfortable with sketching these functions piece by piece, step by step, and really go through it. All right, guys, I'll see you soon. Take care.